Hello, everybody. So this is the first video lecture on the chapter of consciousness and its variation. That's a fun word to say. So first off, we're going to talk about what is consciousness. Of course, that's a huge philosophical issue, and I'm not really going to go down the rabbit hole of talking about philosophy. So let's talk about consciousness from a psychological, from a basic psychological definition is your awareness, a person's awareness of their immediate thoughts, sensations, memories, and environment. So when I am consciously aware, I am attending to something. So here we get this word right here, attention. So our consciousness is always changing as our thoughts change, as the environment that we're in changes, as our physical sensations change, so does our conscious awareness. Attending, when we say we have to attend to something, that means we are focusing on it. If you have ever taken, actually this chapter will talk about what consciousness is, but also all other kinds of consciousness, such as being intoxicated, being asleep, or meditating. So meditation is a form of consciousness where we are probably focusing on our breath or maybe our posture or things like this. There is a philosopher, William James, who coined the phrase stream of consciousness. One of the assignments, I don't recall if you've already had it, you may have already had this assignment, or maybe it's this chapter, is I ask you to be introspective, to think about your thinking, right? And the question that I ask you is, do you believe that consciousness and thought acts like a stream? And the idea of it being a stream was that it's ever changing, much like a stream, but sometimes if there's like a big rock or a log in the river, then or the stream, that causes the stream to change, right? It's still a stream and it's still in the same place, but it has shifted. But our attention, our ability to attend to something, it is limited. And despite what we may have been led to believe in our culture, we cannot multitask. What we call multitasking, or that we can focus on multiple things, is really a very rapid shifting our attention from one thing to another. In this chapter, I assign you a video or a little exercise that asks you to consider how well you are at attending to multiple things. There are a couple classic examples of this. Something is called inattentional blindness. I think I might have this word incorrectly here. Or I think it's called change blindness. And so there's a classic, maybe you've seen it on, it used to be they'd have these 48 hours kinds of things, but it's a classic example of two people and they're talking to each other, right? They're talking about, I don't know, they're focusing on maybe a map or directions, and then somebody walks between them with like a big board or a door, and then the person changes over here. And the challenge is, did you notice the change? When things like suddenly change and you don't notice it, why did you not attend to it? Were you not paying attention? Or one that might be fun for me to try one of these days is, while you're sitting here listening to me, if maybe I go beneath my desk and I come up and I'm wearing different clothes, and did you even notice? Were you not attending? So that's what we mean when we talk about consciousness. One of the states of consciousness is sleep and wakefulness. So our wakefulness is thought to be regulated by a biological clock, sometimes called. So, I mean, if I was in a human growth class, I might be talking about, we have a daytime, a circadian rhythm clock, but we actually have a clock that runs like 30 days or several days. But for our purposes, we're talking about our circadian rhythm. And our circadian rhythm is a biological pattern that it changes pain sensitivity, blood pressure, body temperature, our different hormones, the amount of hormones in our system. All of those things fluctuate over about 24 and a half hours. So just a little bit more than a day. And they are regulated in part, and that's what we see in this picture here. They're regulated by something called a CNS. I'm not going to attempt to say it right here, this word right here, which is a little nucleus along the optical nerve. So the optical nerve is your eyes, so the back of your brain, and that processes or responds to the availability of light, right? Light then regulates your melatonin. So light has implications for melatonin, which is a hormone, and this hormone then affects other systems in our body, which includes like sleepiness, growth hormones, and these kinds of things. So there is a quiz question about, oh, I forget exactly the wording, but the question is about what regulates like our circadian rhythm, or what regulates our sleep and our wakefulness. And the answer is light, because light influences melatonin. Now you can take melatonin, but that's sort of like skipping a step. So one of the there's a what am I trying to say? Some people, when we talk about like jet lag, what is jet lag is when our body's rhythm, our sleepiness and our wakefulness state are out of sync with the clock, right? So if you go from, say, what do they say? It's best to go, rises in the east, sets in the west. So it's easier for us to travel from the east to the west to make our days longer, right? To stay up later than it is to go from the west to the east, because light, daylight, the sun regulates our melatonin production, which then makes us sleepy or awake. The same thing happens if you are working third shift, right? So if you ever work that midnight to 8 a.m. shift, you experience the phenomena of jet lag, which is your body's clock is out of sync with the clock on the wall. And it will make you sleepy when you should be awake. If you've ever worked third shift, and I did very, very briefly, what the research actually on people who chronically work third shift for like decades, is it actually shortens their life expectancy, because our bodies are built to sleep at night when it's dark. And someone who works third shift will be awake. Right, no. Someone who works third shift. So you get off at, say, 8 o'clock in the morning, the sun is just coming up, your melatonin levels are dropping, you become more awake, you go home, you want to go to sleep, but you can't go to sleep because the nature has the sun is up. This is why people get drowsy in the winter when there's more, one of the reasons, when there's less daylight, or things like this. So the point that I'm really trying to make here is that our natural rhythm of our wakefulness is tied to sunlight. And when we try to create something different, right, when we try to create a different version of that, we're fighting against our biological nature. All right, so let's talk about sleep. And I try to end these lectures at 10 minutes, so hopefully I don't have to, maybe we have to crush too much of this in. Sleep is one of these things that our culture has traditionally told us we don't need. And it's traditionally told us that, you can, people, what is it that Shakespeare said? He called sleep the little death, right? That sleep is for lazy people. Well, then some of the new stuff, the research is coming out and it says, no, this is not true at all. Sleep has a biological imperative. People who don't get enough sleep actually have a shorter life expectancy. And I think we'll talk about that on a couple other slides. But the thing from this slide to understand is that the circadian rhythm, this natural rhythm of our wakefulness, also has implications for what we would call our sleep patterns, or sleep. When you hear the notion of REM sleep, or light shortwave sleep, or long wave sleep, what we're really talking about are brainwave patterns, and that's on another slide. But for our purposes, understand that the brain is always active, right? The brain is always active when we are awake and when we are asleep. That as we move through what we would call the short wave sleep, or the light sleep, the non-REM sleep, we have shorter brainwave patterns. When we get to REM sleep, when we think of that as the most common time to dream, but in fact we actually dream in all stages of sleep. These are the longer wave patterns, and our brain is as active during REM sleep as it is when we are awake. The difference is our bodies are paralyzed. Then we have a phenomena called the hypnagogic hallucination, or hypnagogic flinch. We go through 4 different stages of sleep. Depending on different stages of our life, we may spend more time in REM sleep. Babies spend more time in REM when the brain is really active, and older people spend less time in REM when the brain is less active. And this is thought to be related to healing and development Ironically, it is when the brain is more active that the brain is doing more developing and more healing. When the brain is less active, ironically, it seems kind of like paradoxical, right? That when people are more stressed out, they actually spend more time in the deeper wave and the bigger wave sleep. Okay, I'm going to stop that right here since I'm at 10 minutes, and I will start back up basically in the same place.